This video from this series, The Right Side Up Physics, or From Abstruse to Simple, is dedicated to the search for the unified nature of all the forces known to us and has the name The Split of Personality, or Why Gravity and Strong Interactions are Twins. As always, for those who are interested in the purely scientific nature of the problem, at the end of the video there are 5 small pages of text.
Physics is all physics.
The most expensive, overly mathematized, and incredibly complex science, namely physics, has long been in need of a revolutionary cue. It extended its imperial interests from bosons and quarks to the borders of an expanding universe. Its indestructible bastions of petrified formulas and laws, covered with a solid mathematical network of camouflage, guarded by the imperial hordes of scientists. It will be destroyed by some insignificant, but very well aimed fires of a simplicity alien to them, that was brought there by free wind, the wind free from any dogmas. The subject of physics is fundamental interactions in nature. Wikipedia says, scientists have already counted 4 such forces of interactions: gravity, electromagnetism, strong interaction, and weak interaction, but they do not calm down on this and continue to search for the 5th force in the colliders so that they can then find the 6th. But I wonder why all these forces are called fundamental. In the end, the foundation must be one. And here we have the foundation of the universe consists of 4 separate foundations, not connected in any way. This is a very unreliable structure. It seems to me that we should go in the opposite direction, namely, reduce the number of forces known to us, finding family ties between them until we reach the physical root of the dynastic tree of forces. And this root, as we will see later, will turn out to be not only the physical, but also the historical progenitor of forces known to man. As you can guess, we'll talk about gravity. And here we will look for family ties of this weakest of all forces, oddly enough, with its opposite, strong nuclear interaction. To begin with, all forces have one thing in common. Their value at a given point in space is inversely proportional to the square of the distance from the source of force. This is what science says. As proof for us, the following diagram is given. It can be seen that the density of the lines of force emanating from the source of force O and intersecting the segments of the spheres S1 and S2 really decreases with increasing distance in the inverse quadratic dependence. But note that the task was to find the dependence of the force, i.e. the total number of lines of force acting on the same arbitrary body from the distance to it. In this case, 3 inaccuracies are allowed here. We are shown the dependence of the density of lines of force, inaccuracy number 1, passing through different sized segments, S2 is greater than S1, inaccuracy 2, segments of spheres, why say not through a triangle, inaccuracy 3, on the distance to them. The correct illustration for this dependency should look like this. Here, instead of segments of a sphere, One can take a body of arbitrary shape, since the shape doesn't matter for the solid angle. In this case, the dependence of the force on the distance is expressed by the well-known formula of the solid angle, where A is the solid angle at which the lines of force of the source fall onto an arbitrary body. Let us immediately bring this formula to the familiar form of the dependence of the force on the distance x. To do this, consider the flow on field lines through a specific particle that determines the basic physical properties of bodies, namely a Brayton or Newton. Thus, after transformation, the formula for the dependence of force on distance will take the form, where r is the Brayton radius. The behavior of this function at distances greater than 10 to the power minus 14 meter does not differ from the inverse quadratic dependence. But nevertheless, it is important to note that the degree of inverse relationship for all distances will always be more than 2. Strength decreases with distance faster than we thought. The denominator will be not x to the power 2, but x to the power 2 plus some value. For example, at a distance of 1 meter, the degree of inverse relationship will be 2 plus 10 to the power minus 30. This, of course, is a very small correction. However, there is a difference, and it is strongly manifested at the small distances of intranuclear interaction, 10 to the power minus 15 meter, where the degree of inverse dependence of our red curve reaches 1000. That is, the dependence of the force on the distance will not 1 divided by x to the power 2, blue curve, but there will be 1 divided by x to the power thousandth. And here we come to the main thing. This is exactly how the strong nuclear interaction described by the Yukawa potential behaves that sharply decreases with distance, green curve. So, at a distance of only 6 Brayton diameters, namely 6 10 to the power minus 15 meter, it decreases as much as 200 times, while gravity decreases only by 36 times. Thus, our red curve behaves at small distances as a strong interaction, and at all other distances as a force of gravity. This strange behavior of nuclear forces led scientists to invent bulky and complex physical and mathematical constructions to explain this simple phenomenon. In fact, this is one and the same force, which, due to a small inaccuracy, was divided into 2 forces that are diametrically opposed in strength. Entities should not be multiplied unnecessarily. The principle of simplicity says, Occam's razor.
Fisico.
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 Fisico.